Hi everyone, welcome to my video. If you have been following my previous video, you know that I am doing a course on Civil Service Man's Examination Physics paper. So in this video I will discuss about Physics paper 2. This is quantum mechanics. So one by one we will discuss. So you see this and question paper specific instructions here and constant which may be needed. So see this and come to the first questions. Wait and watch. So first question is here. Find the energy of the momentum and wavelength of a photon emitted by hydrogen atoms, making a direct transition from an excited state with n is equals to 10 and the ground state. Also find the recoil speed of the hydrogen atom in the progress. Question number B is here. An electron is confined to move between two rigidity walls separated by 10 to the power 9 meters. Compute the de Broglie wavelength representing the first three allow energy state of the electron and the corresponding energies. Question number C is here. A typically atom radius is about 5 into 10 to the power minus 15 meter and the energy of the beta particle emitted from a nucleus is at most of the order of 1 mega electron volt. Prove on the basis of uncertainty principle that the electrons are not present in the nuclei. So question number D is here. In the Stern-Gerlach experiment using Ag atom, Ag is argentum and Or is gold, argentum is silver. So Ag is argentum atoms of an temperature is 1000 Kelvin, L is equals to 25 centimeter and del Bz by del Z. So proportionals 10 to the power plus 3 Tesla meter. Calculate the separation of the two components. Question number E is here. Using the uncertainty principle, calculate the size and energy of the ground state of the hydrogen atoms. So question number 2 is here. Describe the Stern-Gerlach experiment. Discuss how it is explained space quantizations and electron spins. Find the value of the angle between spin angular momentums S and Z component of the electron moving along the external magnetic field B. So question number B is here. The series limit wavelength of the Balmer series in a hydrogen spectrum is experimentally found to be 3646 angstrom. Find the wavelength of the first lines of the series. Question number C. Compute the allow spectral terms of the two non-equivalent p electron on the basis of Pauli exclusion principle. Come to the question number 3 is here. What is Raman effect? First question. Describe briefly the chief characteristics of the pure rotational spectra. The small rotational Raman displacement for HCl molecule is 14.6 centimeter. Find the internuclear distance between the atom forming the molecules. Question will be explain in details LS coupling and ZZ coupling schemes. Question 3. What is Lamb shift? What is its significant? So significant importance in determining the fine structure of hydrogen alpha Balmer lines of in a hydrogen atoms. Question number 4 is here. Solve the Schrödinger wave equation for a step potential and calculate the transmission and reflection of the coefficient for the case when the kinetic energy of the particle E0 is greater than the potential energy B is greater than B. So question number B is here. Sigma x sigma y is equals to 2 iota sigma z. So 2I sigma z. And 2 sigma square dot sigma x is equal to 0, sigma vector sigma dot vector a, so sigma dot b, so a dot b plus iota sigma dot a b. The prove that prove. So what the right matrix representations of three Pauli matrix sigma x, sigma y, and sigma z. Prove that this matrix satisfies the following identities: sigma x and sigma y. 2i is sigma z, sigma square sigma x. So this is if A we commute with the Pauli matrix. So come to this again. Question number C is here. Calculate the density of the state for an electron moving freely inside metal with the help of quantum mechanics. Schrödinger equation for free particle in a box. So this is Schrödinger time independent question over here. So group section B is here. So explain the deuteron has no excited state. Question number B is what are NA and NOR gate? NO or NOR is gates called universal gate. Give the logic diagrams, Boolean equations, and truth tables of a NOR gate. Question number C is here. What are elementary particles and how are they classified? Describe in brief the different types of interactions that can occur between the elementary particles. Question number D is here. The primitive translation vector of a two-dimensional lattice are A is equal to 2i plus j, B is equal to 2j. Determine the primitive translation vector is a reciprocal lattice. Question number is here. With the help of a schematic diagram, so how entropy and specific heat vary with temperature for a superconductor. A state of a basic assumption of a single particle cell model. How do the centrifugals and spin orbit terms remove the degeneracy of a three-dimensional sphere harmonic oscillators. And question number is here. You see, so that in the nuclear cell model and the level spacing between measured oscillator cell is approximately as cut omega is equal to 41 and a power minus 1 by 3 mega electron volts. Question number C is here. Predicted, so not right, unpredicted, predict the spin and parity of the ground state of the flying nuclei on the basis of the cell model. Oxygen 15, 16 and chlorine 17, 38. So atomic number, atomic mass. So question number 7 is here. You see this. Explain the various leptonic family member. What are leptonic numbers? Conservation. Based on the conservation law, state whether the following reactions are possible or not. You see this? You see. And question number B is here. Write down the quark structure of the following hadrons: delta plus plus minus sigma minus and delta. Write down the following decay in the term of quark. So this is term in the term of quarks. Question number C is here. Explain the unification of electromagnetic and weak instruction. What is Z bosons? What is its relevance in electro-weak unifications? Question number 8 is here. What is the difference between the direct and indirect band gap semiconductor? Which is one is suitable for use in a solar cells? Question number B is here. Obtain Liao equation for X-ray diffraction by crystal so that these are consistent with the Bragg law. Question number C. Write down the silent feature of the Einstein theory of lattice capacity. Further, write down the expression for specific heat in Einstein theory and explain its high and low temperature limit. So I hope so all questions are in the finish. So all related to discussion it for today. Thank you very much and good luck.